All right, guys, let's look at lesson 2, which is gas laws. The first gas law is Avogadro's law. That occurs when you have equal volumes of a different gas at the same temperature and pressure, and that means that they will contain equal numbers of particles. So, for example, 5 liters of neon gas at STP has the same number of molecules as 5 liters of xenon gas at STP. That is because you have the same conditions, same volume, same number of particles. So let's look at a practice. At the same temperature and pressure, which sample contains the same number of moles of particles as 1 liter of O2? Pause the video. Unpause when you're ready. Great, well, welcome back. Well, you should have picked letter A because that will have the same volume and they're gas particles, so they will be equal. All right, let's look at the second gas law, which is Boyle's law. Boyle's law says P1 times V1 equals P2 times V2. So that means that as the pressure on a gas increases, the volume of the gas decreases. There is an indirect relationship here, and we can see that by this graph. We increase our pressure, our volume goes down. Low pressure, big volume, high pressure, small volume. All right, let's look at an example. What happens to a balloon when you squeeze it? Okay, when you squeeze the balloon, your pressure goes up because your volume goes down. So there's an indirect relationship. Let's look at Charles' law. Charles' law is V1 over T1 equals V2 over T2. So that means when the temperature of a gas increases, the volume increases at a constant pressure. So there's a direct relationship there. So temperature increases, volume is going to increase because you want the particles banging against walls the same amount, so you have to increase the volume. So what happens to the car tire in the winter? When the temperature goes down, the volume goes down, and that's why you need to put air in your tires. And Gay-Lussac's law says P1 over T1 equals P2 over T2. So when the temperature of a gas increases, the pressure is also going to increase at a constant volume. So there's a direct relationship there. So that means you increase the pressure and you keep the size of the container the same. The temperature is also going to increase. So how does a pressure cooker work? Is our example. So a pressure cooker works because you increase the pressure by using that pressure cooker. And then what you're going to do is when you increase the temperature, the pressure is going to increase, and it's also going to cook your food faster. And then we have Graham's law of diffusion. So that means that gases are going to move from high areas of concentration to lower areas of concentration, and lighter gases are going to diffuse faster. So which is going to diffuse the fastest, helium or N2? Okay. When you look at this problem, helium is going to diffuse the fastest because it's the lighter one of the two. And it says, why will F2 and AR diffuse at almost the same rate? That's because they are about the same mass. They're about the same size, so they're going to diffuse at the same rate. So let's look at the first, check your understanding. Which sample at STP has the same number of molecules as 5 liters of NO2 at STP? We're going to answer this one tomorrow in class. And then we're going to look at this. Which gas law is being demonstrated here in this picture? We're going to answer this one in class.